So today we're going to start chapter 3, and you're going to have a quiz after section 3.4, and 3.1 is going to be all about proofs. So deductive reasoning is the process of reasoning logically from given statements or facts to a conclusion. Hey, again, if you need to pause the video to finish writing, again, please make sure that you do so. Hey, a proof is a convincing argument that uses deductive reasoning. Hey, so anytime that you're asked to write a proof, you're going to write something called a two-column proof. Okay, and it's always going to be organized into statements and reasons columns. So your statements are always going to go on the left and your reasons are always going to go on the right. And each statement must be justified in the reasons column. So we're going to go through a couple of definitions and what your conclusions you can draw from those definitions. And then in a second, you'll see how they'll end up being used inside of a proof. So basic terms for a proof. Okay, so given that C is the midpoint of AC, definition, if it's a midpoint, it's going to make two congruent segments. So the conclusion that you can draw here, you can say that AC is going to be congruent to CB. For the second one, we have perpendicular lines. And again, how do I know that I have the perpendicular lines? I have that box in the corner. And again, that's the symbol for perpendicular. So MN is perpendicular to AB. And the thing that's special about perpendicular lines is that they make right angles. So your conclusion is that angle MNA and angle MNB are right angles. Okay, again, seems obvious. It's all stuff that we've talked about in the past, but again, you're going to see them come into play in a proof in just 1 second. So for angle 1, we have BD bisects angle ABC. Again, when you bisect an angle, it's going to cut it into two congruent angles. So the definition, again, is that it makes two congruent angles. And the two angles that are going to be congruent are this angle here and this angle here. So our conclusion is that angle ABD is congruent to angle DBC. Okay, and not only can we bisect an angle, we can also bisect a line segment. So line L bisects segment AB. And again, if it bisects, it's going to cut it into two congruent segments. Again, it is not the line that is being bisected. You can't bisect a line. You can't bisect infinity. It's the segment that's getting bisected. So it's AB that's getting bisected. So here we're going to be able to say that AO is congruent to OB. Okay, some other things that you're going to be able to use inside of a proof is properties of equality. So let A, B, and C be any real numbers. So we have the addition property. If A equals B, then A plus C equals B plus C. Okay, again, letters, it's hard to realize. And again, this is really stating something that seems very obvious, but again, you're going to have to write it inside a proof. So if you have A equals B, let's say I made A 2 and B was equal, that would have to be 2. C can be any number. So how about I make it 3? So I'm going to take A and add 3 to it, and I'm going to take B and add 3 to it. So if I add 3 to both of those, I'm going to get 5 and 5. Okay, so that's just using numbers. Again, you'll see how it's going to come into play in geometry in a second. But again, if A equals B, then A plus C equals B plus C. And the exact same thing is going to hold true for the subtraction property. Again, if A equals B, then A minus C equals B minus C. So again, if I pick a different number out this time for A, I'll say it's 5. That means B would also be 5. And something for C. How about I let C be 4? So if I subtract 4 from A and 4 from B, I would get 1 and 1. And again, 1 equals 1. Okay, the reflexive property, again, this is going to come into play in the majority of the proofs that you're going to do are going to involve the reflexive property. Okay, and think of the reflexive property as your reflection. You're looking at yourself. So the reflexive property says that a value is equal to itself. So for example, A equals A, or you can have a line segment that equals a line segment. So AB is congruent to AB. And the substitution property, if A equals B, then B can replace A in any expression. Again, with letters, it's hard to see. But again, if I had the simplest equation, x plus 4 equals 10, subtract 4 from each side, and x is going to equal 6. If I wanted to check my equation, I could substitute. Since x and 6 are the same thing, I can take that x out and plug in 6. And right there, that's the substitution step. Again, we're not going to be doing it with numbers. We're going to be doing it with line segments and angles. But again, to give you an idea of relating it to numbers so it's a little bit easier to see. So that's all the information that we're going to use inside of our proofs. So now we're going to actually start our proofs. So our example, write a 2-column proof. And here's what you're given. You're given that M is the midpoint of PQ, and we want to prove that PM is congruent to MQ. Okay, so again, you have your picture over on the right-hand side. And the first thing that I like to do, there's 2 things I like to do. I like to mark my picture from what's given. And then step number 1 is to always going to be write your given. Okay, so given M is the midpoint of PQ, that's going to mean that PM is congruent to MQ. Okay, so we've pretty much already shown what I want to prove. I want to prove that PM is congruent to MQ, but now we need to actually write our proof. Okay, so the first statement is usually the given statement. It's always the given statement. And what was our given? M is the midpoint of PQ. And what's the reason that we know that? It was given. So step number 1 is always going to be the given. Now, as we get further into this, today it's very basic, so there's always going to be one given. If you have more than one given, you can separate that into step 1 and step 2 and make 2 different givens, or you can write them all in the one statement and say given. Okay, and now each statement should follow logically from the previous statements. Okay, and the last statement is always what you want to prove. Again, this is simple and straightforward. Right away, I can have what I want to prove here. So PM is congruent to MQ. And why is that? It goes back to that first slide. Definition of a midpoint. You cannot say definition of a bisector here. You weren't given a bisector, you were given a midpoint. So again, you're just always using what's given inside of that proof. Okay, so for our second proof, we have BD bisects angle ABC. So again, if it bisects ABC, that means it's going to cut ABC into 2 congruent angles, which means this angle is going to be congruent to that angle. And look at what I want to prove. I want to prove that ABD is congruent to DBC. So this is going to be as straightforward as the last proof that we just did. So again, for step number 1, I put in BD bisects angle ABC. And how do we know that? It comes from right up there. It's given. Step number 1 is always our given. And again, right now we're doing this straightforward. So our step number 2 is going to actually be what we want to prove. Right away, I can tell you that angle ABD is congruent to angle DBC. And that is because you have the definition of an angle bisector. Definition of angle bisector. Okay, again, these are going to get, this is like stating the obvious right now, but they're definitely going to get more involved. Okay, bringing in another definition that we know about. So here we're told that CD is perpendicular to AB, and we want to prove that angle CDB is congruent to angle CDA. So again, if CD is perpendicular to AB, I'm just going to put my little box in there. There we go. That's perpendicular. And again, I already wrote my given in there. The only thing that we know is that CD is perpendicular to AB, and that's given. And again, back from that first slide, what do you know about perpendicular lines? They form right angles. So all I'm going to do in step 2 is state my 2 right angles. So that one that I have marked off on in blue to the right-hand side of the figure is going to be one of my right angles, and that one that I just marked on the left will be my other one. So angle ADC and angle CDB are right angles. And why is that? Definition of perpendicular lines. Okay, and once I know they're perpendicular lines, and once I know that they're right angles, the next thing that I can say is those two angles are congruent. Why? Because, again, right angles both have 90 degrees in them. So for the last step, we're going to have angle CDB is congruent to angle CDA, and that's because right angles are congruent. Okay, every single angle has 90 degrees in it. That's a right angle. So every right angle is going to be congruent. Okay, so here's another one involving some more angles, but different types of angles here. Okay, so we're given that angle 1 is congruent to angle 4, and we want to prove that angle 2 is congruent to angle 3. So again, I'm just going to mark off in my picture, angle 1 is congruent to angle 4, and eventually we want to prove that angle 2 is congruent to angle 3. So again, the first thing that I did in my statements was write down the given. I know that angle 1 is congruent to angle 4 because it's given. Okay, now the next thing that I'm going to do is I'm going to talk about vertical angles. Another thing that I know is that angle 4 is going to be congruent to angle 2, and angle 1 is congruent to angle 3 because those are vertical angles. So I'm going to put that both into one statement. So angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. And that is because vertical angles are congruent. Okay. And now here's where we're going to see that substitution step come into play. Okay. So the next thing that I'm going to say is I'm going to say that angle 1 is congruent to angle 2. Okay. And why is that? That is because angle 2 is congruent to angle 4. So if I go back up here and there's angle 4, I just know from step 2 again that angle 4 is congruent to angle 2. So basically I'm going to take out that 4 and plug in angle 2 from that step right there. So angle 1 is congruent to angle 2, and that's going to be by substitution. Okay, and then the last thing that I'm going to be able to say is that angle 2 is congruent to angle 3. Okay, and again, why can I say that? Let me change colors. Okay, this is coming from this step right here. I have angle 1 is congruent to angle 3. And here's angle 1 again. So I'm going to take that 1 out and plug in that 3 from this step above and have angle 3 is congruent to angle 2. Or again, if I say that the opposite way around, angle 2 is congruent to angle 3. And that's by substitution. Okay. So there's one involving substitution. So we're going to do 2 more, one involving addition and one involving subtraction. Okay, so in 5, we're given that AC is congruent to BD. So I have AC is congruent to BD, and we eventually want to prove that AB is congruent to CD. So again, if you look at my little squigglies there, I need to go from a larger line segment to a smaller line segment. Okay, in other words, AC is bigger than AB. So I'm going from something bigger to something smaller. So what operation would bring you from something bigger to something smaller? It's going to end up being subtraction. But before we do the subtraction step, we're going to have to say what we're subtracting out. Notice that the 2 line segments, AC and BD, overlap at BC. So that's the part that I want to get rid of. So the first thing I'm going to do in order to get rid of BC is use the reflexive property. And I'm going to say BC is congruent to BC, and that is because of reflexive. Okay. And now for the next step, what I'm going to do is I'm going to do subtraction. So for the top piece, I'm going to take this AC and I'm going to subtract out BC That's going to leave me with AB. Now, since this is the first one that we're doing, I'm going to write out the subtraction step. You don't necessarily have to write out the subtraction step if you can see it. But again, since it's the first one that we're doing, so I'm doing AC minus BC. Okay, and what that's going to leave me with again is going to be that AB. Okay, and on the other side, that's going to equal BD minus BC, and that's going to be CD. Okay, so or AB equals CD. So you don't necessarily have to write this. You can go straight to this step if you can see it. Again, first time that we're doing it, didn't want to leave anything to your imagination, and that's going to be because of subtraction. Okay, and then one more, and this last one is going to involve addition. So this time we're given that angle 1 is congruent to angle 3, which is already marked in my picture. And again, my step number 1 is always my given. So 1 is congruent to 3, and I want to prove that angle AEC, which is that angle there that's marked in red, is congruent to angle BED, which is this angle here that I marked in blue. Okay, so again, you can tell that they overlap somewhere. Where do they overlap? They overlap right here where you see both the blue and the red at the same time. So again, anytime that you have something that overlaps, you're going to need to use the reflexive property. So the part where they overlap is angle 2. So I'm going to say angle 2 is congruent to angle 2. And again, that's because of the reflexive property. Okay, and again, this time I want to go from something smaller. Angle 1 was smaller than the big red angle. And again, angle 3 was smaller than the big blue angle. So if I want to go from something smaller to something bigger, we're going to have to do addition. So again, I'm going to write out the addition step. You technically don't have to write out that step. But what am I doing? If I take angle 1 and add angle 2 to it, it's going to give me my red angle of angle AEC. And on the other side, I'm going to have angle 3 plus angle 2. Again, I'm adding step 1 plus step 2. 1 plus 2, 3 plus 2. And again, that is going to be angle BED. And that reason right there, we added the same thing to both sides. That's addition. Okay, and that is the basics of a 2-column proof.